Hi guys, this is Tyler. We're going to review the FRQ for polar equations. So let's do this real quick. So let the graphs polar curves of r equals 3 and r equals 3 minus sine 2 theta are shown in the figure above for 0 theta to pi. So for part A, ignore this mess over here. Let's focus on reading A. Let R be the shared region that's inside the graph of R equals 3 and the inside graph of R equals 3 minus 2 sine 2 theta. Find the area of R. So the question asks you to find the area, right? And what's this area? This whole shared region over here, right? Now, the steps is that, well, the first step, well, actually, what you need to know is that the polar area is displayed over here. And remember that this has to be radians only. So number one, set the r's equal to each other to find the intersections to use the integration limits. So a little bit of simple algebra over here. And I got theta equals 0, comma, pi over 2, comma, pi. These are all the intersections that these guys are equal to. Now, we find the area. So I use two integrals because from 0 to 2 pi, this portion over here, that little portion that looks like a shoe, belongs to that function over here. So that's why I use 1/2, no sorry, not 1/2, but I use that function that matches this integration limit from 0 to pi over 2. And this 3 over here, if you notice that pi over 2 to pi creates that perfect little arc of 3. So this matches over here with respect to the integration limits from pi over 2 to pi. And when you evaluate these, you add this area and you add this area. Notice that I split these up right here. This will equal to approximately 9.708 and 3 decimal places, of course. Otherwise, points get taken off. So that's it for B. Now, if we go from, I'm sorry, not B, A, part A. So now, if we go for part B, for the curve r equals 3 minus sine 2 theta, find the value of dx and d theta at theta equals pi over 6. Now, if you remember, this ratio over here, well, not ratio, but this x in terms of polar equations, r equals cosine theta. So you have to plug in r inside the 3 minus 2 theta, 3 minus 2 sine 2 theta, right? Times the cosine, times the cosine. And then when you take a derivative, you use a product rule because you're multiplying this and that over here. So yeah, when you do that, I basically just evaluated the cosine and sine when theta equals pi over 6, just to make it more easier. And then you just combine like terms over here, get common denominators, and also combine the terms, and you get this answer over here. So that's it for part B. Alright, this one, part C, is a little bit interesting. So they're asking you to find, oh my god, they're asking to find a distance from 0 to pi over 2. So which is, no, when they're asking to find the distance between uh, 0 to pi over 2, they're asking of like how much the distance is changing. So your arrow function is r equals 3, and your inner function is 3 minus sine 2 theta. We do that to find the gap. So when we do that, we get 4 cosine 2 theta when you take derivative of 2 sine 2 theta. So when we take the derivative, you get 4 cosine 2 theta. And then you plug in theta equals pi over 3, which you get a negative angle, which is negative 1/2. And then you get negative 2. So that means that like as theta increases, the distance decreases as well. So if you refer back to the unit circle, the 0 over here. So this relationship, when you increase more theta, is that pi over 6. When you evaluate from pi over 6, this becomes 2, which is right here. And this is a positive angle, which is 2. Now, if as you increase more theta, pi over 4, 2 times pi over 4 is pi over 2. And then we know that the cosine of pi over 2 is 0. So 4 times 0 is 0. So that distance becomes 0. Now, they're asking for pi over 3, which is what we answered, which is -2, right? Notice that this relationship, as you increase more theta, it gets less and less. And then whatever this side that's greater than pi over 3, it should be less than -2. So this is more negative value. And so I mean, in this scenario, they're asking for theta equals pi over 3, which is -2. Now D, particles moving along the curve, r equals 3 minus 2 sine 2 theta, so that the d theta over dt equals 3. For all times of t is greater than 0, find the value of dr and dt at theta equals pi over 6. So we know that d theta over dt equals 3, which is really nice. And when we take so d theta over dt equals 3, and they give us this r function over here. So what we have to do is that we have to take a derivative of dr and d theta with this function over here. So that gives us negative cosine 2 theta. And the whole point of finding this derivative is that we can perform a cancellation technique, which is over here. So dr and d theta is the same thing as dr d theta. Oh, sorry, dr and dt is equal to dr and d theta times d theta over dt. You cancel out the d thetas, which is equal to negative 4 cosine 2 theta times 3. And then when you plug in theta equals pi over 6, negative 12 cosine 2 pi over 6 right here is equal to negative 6 over here. So that's the value of dr and d theta. So I think that's it. That's all I had to cover from from A to D.